Now in this lesson, we're going to look more specifically at some SolarEdge characteristics and behaviors and explain how their optimizers and inverter work together. First, we have to lay out some specifications of all the hardware. The new HD wave inverter is designed to get a fixed nominal voltage of 380 volts DC from this series string of optimizers. They choose this voltage so that they can do their H-bridge switching and filtering and produce the output AC voltage at 240 volts most efficiently. So all the optimizers in a string work together during the day so that their cumulative voltage is always 380 volts. For their larger inverters, it's about 400. Each optimizer doesn't have to be exactly the same, but they have to add up to be 380 volts. They specify that you need a minimum of 8 optimizers and modules to make a string, and a maximum of 25. So let's work with 8. So if we have 8 optimizers in our string, and they need to add up to 380 volts DC, then each one would output at 47.5 volts DC, assuming everything is balanced and equal. The question is, how much current would each one be outputting? Well, that depends on the power output of the array. Let's say that all the modules are the same, and each one is producing 280 watts, when it's hot and everything. Well, 8 modules producing 280 watts each means the whole array is producing 8 times 280, or 2,240 watts. And since power equals current times voltage, and that power is at 380 volts, then the current would be 2,240 divided by 380, or 5.9 amps. So that means that each optimizer is outputting its 280 watts at 47.5 volts and 5.9 amps. So this is how it works when everything is all the same and balanced and even. Now let's look at what happens when a module produces less than its neighbors. Now, this could be because it gets shaded or because it's facing in a different direction. The cool thing is that each module and optimizer operate as a single unit, and the optimizers all work together to adjust their output. So let's see what that's like. For this example, let's say one module is only outputting 100 watts, so it's almost 1/3 of its neighbors. Well, first of all, the total power from the array will drop by 180 watts to 2,060. Now remember, the inverter always wants to operate with its DC input at 380 volts. So the current at that voltage from the optimizer string would need to be 2,060 divided by 380 volts, or 5.42 amps DC, not the 5.9 that it was before. Since the optimizers are wired in series, they all have to operate at the same current. It can't be larger in one and smaller in another. The currents have to all be the same. So all the optimizers change how they operate. The regular optimizers still have 280 watts from their solar module to optimize. So if that 280 is to be output at 5.42 amps, that means that they need to operate at 280 divided by 5.42, or 51.65 volts DC, not the 47.5 that they did before. So they have to go up a bit. And the affected module is only producing 100 watts. So if its optimizer is to make the same current as all the others, 5.42, then it has to operate at 100 divided by 5.42, which would be 18.45 volts DC. But the result is that now you have one optimizer contributing 18.45 volts and 7 others contributing 51.65, and that all adds up to 380, just what the inverter requires. Now, here is one difference, perhaps a disadvantage, of optimizers compared to microinverters. The minimum number of micros in one circuit can be just 1. However, in order to operate the string inverter down on the ground, there is a minimum of 8 optimizers and modules that need to be on any one string. But on the other hand, when comparing the maximum number that can be on one circuit or string, the optimizer solution has the advantage. With N-phase microinverters, you can have a maximum of 16 on any one branch circuit. And if you need more power, then you have to start another circuit. But with SolarEdge optimizers, you can have up to 25 optimizers and modules in a single string. That might end up saving you a lot of money in terms of materials and time when you're doing a large install. It's worth taking a second to go over some SolarEdge history, as it's such a dominant player in the solar market today. SolarEdge was founded in 2006 with headquarters in Israel. It really began mass producing and shipping its optimizers and inverters in 2009. They had their IPO in March of 2015 and raised $126 million. Shortly thereafter, in May of 2015, they were the first to announce a partnership with Tesla to offer the new Tesla Powerwall combined with a modified string inverter, which would provide integrated lithium-ion storage with solar PV. And then in September of 2015, they announced their new generation of inverters, the HD Wave products. And recently in July of 2017, they announced the first inverter-integrated high-current electric vehicle charger. We can end by looking at the market share that SolarEdge now has compared to the other brands and types of inverters in the US market. You can see that back in 2014, SMA and Enphase were both at about 30% market share, and SolarEdge was at about 15%. But now, SolarEdge seems to have almost 70% market share and dominates over all the other choices. I think it's a combination of their lower price and their module-level power electronics capabilities. It's a pretty great technology story.